Hi, it's Miss Lanou again. So today we have a lesson on adding and subtracting rational expressions. So this is going to be a lot like adding and subtracting fractions. Okay, remember rational expressions we can think of like fractions. So the first thing to keep in mind is if we're talking about adding and subtracting things that have the same denominator, okay? You want to keep the denominator the same and add or subtract the numerators. So for example, if I have a over c plus b over c, that's simply a plus b over c. If I'm subtracting two quantities, a over c minus b over c, that's going to be a minus b over c. You probably remember doing this with fractions. For example, if you have 12/5 and you want to add 7/5, well, that gives you 19/5. I took 12 plus 7, that's 19, and put it over the denominator of 5. Okay, if we had something like 15/5 plus 5/5, okay, that's going to be 20/5, and remember, you can simplify 20 over 5, so that is just 4. So we're going to be doing the same thing now with rational expressions, so expressions that include numbers and variables now. The first example we have is the simple case of 7 over 12x minus 5 over 12x. Okay, so we're going to keep our denominator of 12x, and we simply subtract 7 minus 5, and that's 2. So we have 2 over 12x. Now if we factor 2, is just going to be 2, and then 12 is 2 times 6x, so we have a 2 over a 2, and those cancel each other out. So that simplifies to 1 over 6x. And that's your final answer. So we want to make sure that not only do we subtract the numerators, but then in our final form we simplify that answer. So let's look at the next case. So we have 2 over 3x squared plus 1 over 3x squared. The denominators are the same, so we keep that the same. And then we add 2 and 1, that gives us 3. So we have a 3 on the top, a 3 on the bottom, and they're both factors, so the like factors cancel out, which gives us 1 over x squared. Okay, the next example. So we have 4x over x minus 2 minus x over x minus 2. We keep our denominator of x minus 2, and then we're going to subtract 4x minus x. Okay, I wrote that out. Now, you can combine like terms here. So 4x minus x, that's going to be 3x, and then on the bottom we have x minus 2. We want to check and make sure each polynomial is factored fully. X minus 2 is factored fully, and we don't have any common factors in the top or the bottom, so that is our simplest form of our answer. Okay, let's look at the next one. So we want to keep our denominator of x squared plus 1. And now we add our numerator, so we have 2x squared plus 2. Okay, then we want to look for, can we factor? So 2x squared plus 2 both have a common factor of 2, which leaves x squared plus 1 on the inside. Then on the bottom, we have x squared plus 1. Okay, it's on the top and the bottom of this fraction, so those cancel out, and our answer is simply 2 over 1, or just 2. Okay, next we're going to talk about finding the least common multiple of two expressions. This is going to come in handy when we're when we're adding and subtracting rational expressions that don't have a common denominator. So this is an important skill to have for the next step. The LCM, or least common multiple. To find it, we want to factor each expression completely and then write each factor to the highest power it occurs in either expression. Okay, I'm going to talk about what that means by showing you some examples. So for example, if we have the numbers 12 and 16, okay, and we want to find the least common multiple of those two numbers. So I can easily make a factor tree of 12, and I know that 3 and 4 multiply together to give 12. But then I want to factor 4 even further, so that I have 12 as a factor of 3 prime numbers, 3 and 2 and 2. So that's called the prime factorization of 12. So I want to write that prime factorization next to 12. So that's 2 times 2 and then times 3. And I leave some space in between each number just in case. Okay, you'll see why in a minute. Then I want to look for the factorization of 16. So 16, I know that 4 and 4 go into 16, and then I can factor each of those to 2 and 2. So the prime factorization of 16 is 2 times 2 times 2 times 2. Okay, then I want to look and take each number only once. So if I have a 2 up here, a 2 down here, I know that my least common multiple is going to have 1, 2, at least 1, 2. Then it's going to have at least another 2. Then, because there's another 2 in 16, I'm going to include that. And because there's another 2 in 16 again, I'm going to include that. 3 is a factor of 12, so that's going to be a factor of my least common multiple. So these are all the factors of my least common multiple. So the least common multiple of 12 and 16 is going to be 2 times 2 times 2 times 2, or 2 to the 4th, times 3. Okay, and that's the same as 16 times 3, which is 48. Okay, so it might get a little more complicated when we have polynomials instead of just numbers. So I'm going to actually insert some space, because I think we'll need some more space for this problem. So if we have 5x cubed and 10x squared minus 15x. So I want to factor both completely. And I want to write each of them as the product of their factors. So the number 5 is a factor here, and then I have x 3 times. So x times x times x. And then in my number 10x squared minus 15x, okay, I can factor out, let's see, they both have a factor of 5 and a factor of x. So I'm pulling out a monomial here. So I'm going to bring that out, 5 and x. And then left over on the inside, I have 2x, because 5x times 2x gives me 10x squared. And then I'm going to subtract 3, just 3, because negative 3 times 5 gives me negative 15. Okay, so I've written each of these in their factored forms. And actually, I'm going to take this 2x minus 3, and instead of writing it right underneath these two x's, I'm going to write it off to the side. So 2x minus 3. Okay, so my least common multiple, I'm going to simply write each number that occurs. So I have a 5, okay, I have an x, another x, another x, and then 2x minus 3. So if I simplify that, if I have 3 x's multiplied together, that's x cubed, so the least common multiple is 5x cubed times 2x minus 3. So that's the least common multiple of 5x cubed and 10x squared minus 15x. Okay, so now we're going to show a more complex example. Okay, and this should be as complex as it probably will get where you're finding the LCM of two numbers. So first we want to factor each polynomial completely. And I'm going to use two different colors, probably blue for the 8x minus 16, and I'll use a different color for the other one. So 8x minus 16, if you notice, 8 goes into both 8 and 16. So that's the largest number that goes out of both. We're going to remove that factor. Okay, and then what's left over, we have x minus 2. Okay, if you look at the number 8, it can be factored further. So you might want to make a factor tree off to the side. 8 is 2 times 4, which is 2 times 2. Or some of you might already know that 8 is 2 to the third power. So we're going to rewrite that as 2 times 2 times 2 times x minus 2. So that is 8x minus 16. Now let's factor 12x squared plus 12x minus 72. Notice how 12, 12, and negative 72 all have a factor of 12. So we're going to bring that factor out front, and then left over we have x squared plus x minus 6. Okay, because 6 times 12 gives us negative 72. And then we've got a polynomial here, a trinomial. We can factor this. We want to look for factors of negative 6 that add up to 1. Okay, and the ones that work, negative 3 and positive 2, that gives us negative 1, so we need negative 2 and positive 3. That'll give us positive 1. So we have 12 times x minus 2 times x plus 3. Okay, that is the factored form, and it looks like we've got a 12 here, so we can rewrite, keep factoring that number 12. Okay, 12 is 4 and 3, which is 2 times 2 times 3. So instead of 12 here, I'm going to write 2 times 2 times 3 times x minus 2 times x plus 3. Okay, so that was for 12x squared plus 12x minus 72. And if we want to look at what overlaps with 8x minus 16, so we'll write those factors underneath, and that has factors of, let's see, 2 times 2 times 2, so we're going to write 2 times 2 times 2, and then x minus 2, so we'll write the x minus 2 below that. Okay, so we're looking at this information right here, and you just write down one copy. Each number gets put in your LCM. Each number is a factor once. So we have a factor of 2, a factor of 2, a factor of 2, 3 is a factor, and then x minus 2 and x plus 3. So that is the least common multiple. And we can actually multiply this 2 cubed times 3. Remember, that's 8 times 3, which is 24. So we have 24 times x minus 2 times x plus 3. And that is the LCM of 8x minus 16 and 12x squared plus 12x minus 72.